All right, guys, since you are not joining today, I'm going to explain this in a video and share it with you. This is a bit tricky one. Program can be used to manipulate data. A program is needed to convert 8-bit binary number into denary. The program must receive an input of binary pattern and validate that it has exactly 8 characters. There's no need to validate that it has only ones and zeros. That's good. Request and the input again if the binary pattern does not have exactly 8 characters. Okay, let's do it step by step. So the purpose is to input a binary pattern like this one and then output the denary number, which is 180, right? So when you are doing this on a theory question, of course, what you do is you write the positional values for all the binary bits starting from the right corner, and then you multiply each number where there's ones, and then you add them together. So 1 into 128, 1 into 32, 1 into 16, 1 into 4, and you add them together. Zeros you don't add because it doesn't count any value. 0 times 64. And that's how you get the denary number. Okay, now in order to do this, you can see that they have given only the denary placeholders, which means these placeholders have been given. Binary number, of course, we need to add. Binary pattern has to be added. Denary number variable is there, count is there. So the first thing I'm going to do is I'm going to validate this binary pattern. I'm going to ask the user to enter the pattern. Right, so I'm going to use it as binary pattern as they have given. Equals, as you can see, it's a text value, it's a string, so I don't need to use int there. Enter your binary pattern. Right, now to the validation. I mean, you just need to validate whether it is having 8 binary numbers. So for that, we can use the length function to get the length. So I'm going to use the while loop because it says uh, request the input again if the binary pattern does not have exactly 8 characters, right? So I'm going to use the while loop. While means as long as binary pattern. We need to take the length of this. So I'm going to take length using len, length of binary pattern not equal to 8. It has to be exactly 8, isn't it? Right? Because it says exactly 8. So if it is not equals to 8, I'm going to ask the user to enter the binary pattern again. Again. Right. Once it is validated, we need to calculate the denary number, but beforehand, I'm going to test this one. 1011. Okay. Enter it again. 1, 2, 3, 4, 5, 6, 7, 8. Fine. Let's enter more than 8 and see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. So the validation works. 1, 1, 1, 3, 4, 5, 6, 7, 8. So the validation works perfectly. When a valid pattern, binary pattern is input, convert the binary pattern into its denary equivalent, right? Okay. Now, right. So, so that is done. Validation is done. Now, next is to check whether ones are there. If it is 1, what you need to do is you need to multiply by this place value and add them together. Okay, what we can do is we can have a loop here to go through all the ones and zeros. So I'm going to use a for loop for uh, bit in binary pattern. right? So I'll be multiplying. mm, I'll be checking each bit one by one, but I'll be multiplying by its place value. So you can see that here the number, if you start from the very first bit in the binary pattern, it can match the first value in the array. Right now, that's an array. Placeholders is an array. So the first bit exactly matches the first place value in the placeholder array. But the thing is, I'm using a for loop to go through the binary pattern, which will go from 1 to 8. But the thing is, this binary pattern place 1 uh, matches with the 0th place in the array because the array starts with 0. So I need to work that out, right? So if I can match that, if I can match the binary bit place 1 and somehow make the array first place as 1, I can simply use the same for loop to do this thing, right? So what I'm going to do is for bit in binary pattern, which will access every bit in the binary pattern. If bit equals to 1, I'm going to add the place value to the denary number. I'm going to keep adding the place value to the binary number. I mean, sorry, the denary number. So denary number equals denary number. This is how you keep on adding it to it. Plus, right? So you're going to keep on adding placeholder value to this denary number if the bit is 1. But you need to remember that if I use the first value, which is denary placeholders, and use the bit here, that's not going to work, isn't it? Because the bit will be 1 or 0, and I should access 0, then 1, 2, 3, 4, and so on and so forth. So this way can't be used. So what I'm going to use is I'm going to use the in range function, right? In range, which will go from 1 to 8. So you know that we need to put 9 there because it goes 1 less than that. So starting from 1, it goes to 8. Now I can use bit here because the is bit is going to be 1, and then 2, then 3, and so on and so forth. But I can't use it like this, bit equals 1, because when bit is put in a for loop like this, it's going to go from 1 to 8. It's not really looking at the bit pattern. So what I need to do is bit pattern has to be used as an array. So if you use like this, bit pattern like that, It's going to use this bit value, or let me call this index. It's better we put it as index, right? So makes sense now. Index, bit pattern index. What happens is bit pattern is going to be treated as an array. You know that if it is a string that we input, the string will be treated as an array. It can be treated as an array. So I can use the index of each character to access individual characters. So bit pattern is an array right now. So if bit pattern index, which where the index goes from 1 to 9, 1 to 8 equals 1, we need to get the placeholder value from the placeholders array and put it into the Denary number. In this case, I'm going to do another modification. I don't really need to start with well, I can't start with the 1 because if bit pattern is also an array, it has to be starting with 0 because arrays start with 0. So then this should be 8. So it goes from 0 to 7, 8 places. And even here, index 0, index 1, index 2, index 3, index 4, index 5, index 6, and index 7. So 0 to 7. So it perfectly matches. Index 0 to 7 and index 0 to 7. Index 0 to 7 in Denary placeholders matches with index 0 to 7 in bit pattern. So you can see that the way I thought earlier was wrong now. I had to modify the code. So I just wanted to go through the same thinking pattern because you may also find out how we change our thinking pattern to get the final outcome. We may not be able to really figure out the exact solution at once. So earlier I thought I could do it in one way, but now I have changed it completely because I found some issues on the way. So now if bit pattern index, which is going to be from 0 to 7 equals to 1, I'm going to add the place value from the placeholders array into the Denary number. So this can't be bit. This has to be updated to index. So index will go from 0 to 7. Right. So only if it is 1, it will be adding the placeholder value to the Denary number. That's what exactly we need. So at the end, we should be getting our Denary number, print a message that contains the binary pattern and its Denary equivalent. Right. So print binary pattern is, we can print binary pattern, and then we can print the Denary number. Denary number is Denary number. Right, so hopefully we should be getting the right answer. Let's see. So the binary pattern we need to test is this one, 1011, 1011, 0100, 0100. Okay, binary or bit pattern is not, okay, it's not bit pattern, it should be binary pattern, right? Okay, again, 1011, 1011, 0100. Okay, so there's a mistake. It hasn't really got updated by a Denary number. There should be some mistake. So there's a logical error. This is a logical error. Let's find out what has gone wrong. Okay, the mistake is very clear. Right. So the problem should be somewhere here because it hasn't really added these numbers into this Denary number, right? So now you know the where the error could occur because the data number hasn't been incremented. And now if you look closely, you see the mistake. The mistake is you are just checking whether it is one, whereas binary pattern is a text, is a string, right? It was earlier added as an input, which is just a string. So if you are checking for string, this has to be within double quotes or single quotes. So that should be the mistake, right? Okay, so now 101, 101, 1, 0, 100. There you go, 180. Worked perfectly. All right, now let me comment on these lines so that you will understand what we have done. Now I'm going to put my thinking pattern into these comments, right? So this is where we input the binary pattern, input the binary pattern as a string. Here we do the check or the validate, the length to be exactly 8. So this while loop keeps going, keeps checking until it's 8. This one, for loop, goes through each bit treating the binary pattern as an array. So remember, if there's a variable, if it has a value, it can be treated as an array, and you can access individual values or characters or digits using its index. So that's exactly what we are doing here. And then here, check each character for 1 using the index which starts with 0. And here, use the same index to access the placeholders if the bit is 1, and add the value and keep adding the value to the Denary number. Yeah, that's the thinking behind it. All right, so let's try something else. 1011, that's 4. 1011. 1, 2, 3, 4, 5, 6, 7, 8. 187. Okay, let's try what happens if you put all ones, right? 1, 2, 3, 4, 5, 6, 7, 8. 255. Right, so hope you understood.